In computer science, algorithms serve as detailed instructions or sets of rules to solve problems or perform specific tasks. These algorithms can be written in various forms, with pseudocode being one of the most commonly used approaches. Pseudocode acts as an intermediary between human-readable instructions and the precise syntax required by programming languages. It is a simplified representation of an algorithm that uses plain language mixed with basic programming constructs, allowing it to be understood without prior knowledge of a specific programming language. Pseudocode plays a crucial role in the development of algorithms as it provides a clear step-by-step structure that can be translated into actual code. Unlike formal programming languages, pseudocode does not require adherence to strict syntax rules, which makes it particularly useful during the planning and design stages of software development. For instance, a programmer tasked with creating an algorithm to calculate the average of a list of numbers could write pseudocode to outline the necessary steps. Initialize a sum variable, iterate through the list to add each number to the sum, and finally divide the sum by the total count of numbers. By expressing these operations in a concise yet understandable manner, pseudocode helps programmers focus on the logic of the solution, without being distracted by the intricacies of coding syntax. It is important, however, to ensure that pseudocode is not overly vague. If pseudocode lacks sufficient detail, it can lead to ambiguity, making it difficult to interpret or implement accurately. Clarity is paramount, as the purpose of pseudocode is to serve as a bridge between conceptual understanding and practical execution. For example, a vague piece of pseudocode might simply state, process the numbers in the list and compute the average. While this conveys the general idea, it fails to specify how the numbers should be processed, what variables are needed, or the precise sequence of steps. Such vagueness can cause confusion and errors when translating the pseudocode into a functioning program. To avoid these issues, pseudocode should include enough detail to define the algorithm's logic unambiguously, while remaining simple enough for easy comprehension. A more precise version of the previous example might read, set the variable sum to 0. For each number in the list, add the number to sum. Count the total number of items in the list. Divide sum by the count and store the result in the variable average. This version eliminates any ambiguity, clearly outlining the steps and variables involved, making it easier for a programmer to convert the pseudocode into executable code. The balance between simplicity and detail is key when writing pseudocode. Including excessive detail can make pseudocode as complex as actual programming code, defeating its purpose as an accessible and abstract representation. Conversely, omitting critical information can render it meaningless. For example, when designing an algorithm to sort a list of names alphabetically, the pseudocode should specify the sorting method, such as bubble sort or merge sort, and describe the necessary operations, such as comparing and swapping elements. Simply stating, sort the list alphabetically, is insufficient, as it leaves too much open to interpretation. In summary, pseudocode is an invaluable tool for expressing algorithms in a clear and structured manner. By carefully balancing detail and simplicity, it allows programmers to outline solutions without being constrained by the syntax of a specific language. The clarity of pseudocode is paramount, ensuring it serves as a reliable blueprint for implementation. With well-written pseudocode, the transition from algorithm design to coding becomes seamless, reducing errors and enhancing the efficiency of the development process.